And I want to welcome back to the podcast, Karen Hurd. Welcome back.
Thank you. I'm very pleased to be back.
I'm not alone in loving having you on. Whenever I have you on, so many people listen and write in, and thousands of people just love your work and find your not your schools, but your courses, from these podcasts, and they're really getting a lot of healing. So I wanted to thank you for that.
Good. I'm very pleased to hear that.
Yeah. I'm excited to talk about sugar. Sugar has been my vice. That's the place where I've always had, a tendency to go when I'm trying to regulate myself. So I want to learn everything we need to learn today about that. And I want to know where we begin.
There are so many aspects of how negative sugar is that I'm going to cover the major ones today, if that's all right. And so I need to start out with what I call the roller coaster sugar reaction, so we can understand how insulin is being produced and how that has an effect on the entire endocrine system. The endocrine system is a system of glands that produces hormones for us. So this is like an underlying basic foundation. And then I've got to branch out into how we get into inflammation, and it reduces immune system function, how it causes Alzheimer's, and etc. It goes into a lot of stuff. So I will, if it's all right with you, I'll just launch into this reaction of how.
Yeah, definitely. I'm getting my paper so I can write little notes. Go ahead.
Okay. What happens when we take in sugar? You need to understand sugar is very easily absorbed. Some things take a lot of time to break down and enter into the bloodstream. That is not so with sugar. Whenever we put in sugar, it's a what we call saccharide. Its molecular construction is such that it takes very little digestive effort, basically none, for it to cross the barriers that then allow it into the bloodstream. So we take sugar into our mouth. And so we're eating whatever the sugary thing is. And this is then absorbed from our mouth, the sugar, the glucose. Glucose and sugar, I'm going to use those terms synonymously. The glucose, the sugar, is absorbed from our mouth at 30%. So if you're eating some sweet concoction, 30% of the sugars in that sweet are going to be absorbed while this is in your mouth. Now you think about this. How long are you chewing a cupcake or whatever it is, a piece of candy? This is really quick. That's why diabetics who are having a low blood sugar reaction, it means their blood sugars are getting too low, and that's usually because they have taken too much insulin. Then they can just take something sweet, and it's not like, 5 minutes later, 10 minutes later, they pop out of this because their blood sugar is coming up. No, this is instantaneous because we have this 30% absorption in our mouth. So then the sugar, you swallow it, it goes down your esophagus, it goes into your stomach, and you are absorbing sugar from your stomach. By the time you reach the duodenum, all the sugar is absorbed, because these carbohydrates, sugar is a carbohydrate, is so easily absorbed as in comparison to like proteins, which take a very long time to break down. They're broken down in your duodenum, your jejunum. Fats take even longer to break down because they are mostly broken down in your large or your small colon just before it enters your large colon. So this is very, very quick reactions. So, this is nice. I mean, if you are diabetic and you're having an insulin reaction, you need to have sugar quickly. Well, it'll work quickly. Well, what does it do for the regular person? And it actually adds to diabetes. We know that diabetes is a result of sugar consumption. But what does it do to the person who doesn't have diabetes, or how does it lead to diabetes? When you take in these sugars and they're entering the bloodstream at such a rapid rate, your blood glucose level is increasing dramatically. Normally, we want our blood glucose levels to stay between the number 70 and 120. It can be a little bit different than that. It can be a little bit higher or lower, and you're not in any danger. But if you get too much higher or too much lower, then you can be. And so your blood glucose is going to do what we normally want to see, is this gradual increase and then a gradual decrease. So we're not quite on a level line, but I mean, it's so gradual slope coming up and then coming down. That's the way the body wants it. However, when we eat sugar, when we eat sweet things, we have an immediate spike. This is no gradual. This is a spike. And so you will jump up. You can be jumping up many points per second. Points are, we measure glucose. I mentioned 70 to 120. We have these, we call them points. And so you could be jumping up several points in just a few seconds. Well, if you get up too high, when you're starting to run in the 1,000 and the 2,000 level of blood glucose, you're extreme danger of dying, of a condition that causes your brain to flood with so much sugar. And I'm going to discuss this further, because your brain is taking in, soaks up this sugar, that you actually will stall your brain so it doesn't function anymore. This is called diabetic coma. It is a fatal state. And so the body, as your sugar are spiking, the body doesn't go, oh, this is very interesting. Sugars are spiking. Wonder if they'll go into diabetic coma and die. No, the body goes, do you see what's happening? This woman's blood glucose level is spiking at this many points per second. And we have about less than 5 minutes and she will be dead because of diabetic coma, because we have flooded, we've too much sugar to the brain. And so then what does the body do? It immediately does a red alert, Houston, we have a problem. We have got to get these sugars down right now, not tomorrow, not in the next hour. Instantaneously, we have to bring these sugars down because we're looking at just a few moments and this person is going to die. So how do we bring the sugars down? Because they're, you're still sucking on that piece of candy. You're still stuffing another donut in your mouth, whatever you're doing. Well, we have to bring out a hormone. So now we're into an endocrine system, a gland that makes a hormone that will reduce the blood glucose level. The gland's name is the pancreas, and the hormone that it's going to produce is insulin. And so insulin is released. Well, how much insulin? Just a little dab of insulin. No, you produce insulin in response to the spike. So if you're going up really rapidly with your blood glucose levels, you're going to release a boatload of insulin to bring down your sugars just as rapidly. Insulin is very effective. It actually grabs these sugar molecules in your bloodstream and will convert them into something known as a triglyceride. It's also known as a triacylglyceride, or they're the same, and it's the same number that you see when you get your cholesterol levels checked and they check your triglycerides or your triacylglycerols. It is exactly the same. And this becomes important because the triglycerides, they are not a sugar anymore. They are a fat. And they have to be stored somewhere. If they stay in your bloodstream, they will cause you to be, they coat the outside of all your cells. And so you become resistant to insulin. And insulin is important to trigger receptor sites on your cells so that the sugar can enter into the mitochondria of the cell and provides energy for the cell to do its job. But when you have these triglycerides, they're like a coating of grease over the receptor sites. And so then you can't have the insulin that's supposed to be helping the sugar enter the cell and then also leave the bloodstream. So they're not converted to triglycerides and can fuel the cell's energy factory. And so then you can't make that happen because the grease is coating these cells. And so then the triglycerides stay in your bloodstream at a higher level, which then means you have something called insulin resistant type 2 diabetes. Welcome to the world of diabetics. And most type 2 diabetics, before they're diagnosed and before they get on medications, will always find that they had very high triglyceride levels. Well, yes, that's because this whole mechanism. Well, how did we get these triglycerides? Because you had to release insulin because you were eating sugar at such a great rate. And
so let's pause there a minute.
Sure.
I want to just kind of soak it in and give a little like feedback to the listeners to make it bite-sized.
Okay, sure.
And I'm going to ask you some questions. So I'm understanding this cycle. We take in sugar, our blood glucose goes up in seconds. Second by second, the glucose levels are rising. They go well above 120. The body says, this is actually, it's a survival response, isn't it? I'm assuming we make adrenaline at the same time to alert the body.
Right. Yes, you're going to make adrenaline as the cycle goes on. I was going to explain that, but can I interrupt you just a moment?
Please.
Because you're not necessarily above 120. You're supposed to stay in that range. but it's the rate of increase
Got it.
that the body responds to. So you could be at 80 or 90 at a normal blood sugar, but you're rising so rapidly that you're going to kick in this response before you even go over the 120, because it knows
Got it.
we have only so many seconds, and then you're going to be up into the 1,000, 2,000 range. And so it stops this while you're still in the normal range.
So, great. So you're eating the sugar, the body's noticing that the spikes are happening so quickly. The body's saying, at this rate, we're going to go way above what we can handle. So even when you're in a healthy blood sugar range, your body's still making the insulin to convert this sugar into a triglyceride.
That is correct.
And what's interesting about that to me is that also relates to people who have high cholesterol and heart issues, because I remember triglycerides, and obviously correct me if I'm wrong, the structure is like a coily kind of barbed structure, and doesn't cholesterol get stuck on them in the veins?
Yes, it's actually, when you look at cholesterol, we're most concerned with LDL, that's low density lipoproteins. High density lipoproteins are a really good cholesterol. We like those. Okay. The low density lipoproteins, when you take it apart and you look at the molecular structure, a low density lipoprotein is a triglyceride core. It's all made of these barbed, spiky little triglycerides, and then it's covered with what we call an apolipoprotein shell. An LDL molecule is basically just a big old ball of triglycerides with a little shell around it.
Mm. And that can impede the flow of that cholesterol, the LDL, and then we have high cholesterol because it's getting stuck in the circulatory system.
Yes,
which
as it
impacts
oxidizes, because then it
right.
oxidizes easily, and then once it oxidizes, it becomes very sticky, sticks to the inside of the arterial walls, and then it closes off that lumen, that opening. So then you have less space to move the blood through, and then we can get clogged arteries. We call it atherosclerosis. You can have a myocardial infarction, heart attack.
Right. I mean,
brain, it blocks the carotid arteries. Is bad.
I think it's important to kind of just hover there for a moment, because I've worked with so many clients over the years that have really high cholesterol or heart issues, and they stop all fats and they stop all these kind of healthy foods, but they don't stop the sugars and they don't stop the flours, like the white flours. And when they stop the sugars in the white flours, the triglycerides dissolve essentially because nothing's feeding them. Is that right?
That's correct.
That's so interesting to me.
Yeah.
So one thing I want to ask before we go in, I definitely want to go into the endocrine and the adrenaline more. I just want to take little bite-sized wisdoms from what you're saying first. It's important, I think, for the listeners to understand that the body runs on glucose, that everything we're eating, all of our delicious whole foods are essentially broken down into glucose to feed the cells. So can you just give us a little bite-sized information about that process so we can understand why glucose is already something our body really requires anyway, and why it's so confusing when we eat sugar?
Right. It's because sugar is a carbohydrate. We have to have carbohydrates to exist. Without carbohydrates, carbohydrates are providing the energy that cells need to be able to do the job. We have to have some source of energy. There's something called a TCA cycle. It's a tricyclic acid cycle, and are also called a Krebs cycle. And then we have this mitochondria, which is a part of our cell. Inside every cell, we have things called organelles, parts of the cell. And one of those parts is a mitochondria. It's the fuel burning energy factory of the cell. And so we have to have something to burn. You got to have gas in the tank. You got to have diesel in the tank. You got to have, some type of fuel to run this. And carbohydrates are the primary fuel. We can use fats. Proteins have to be converted into carbohydrates, but carbohydrates is our number one fuel. So that's why we get confused, because you can have broccoli. Broccoli is a carbohydrate. You can have whole grain bread. That's a carbohydrate. You can be eating rice. That's a carbohydrate. Oatmeal is a carbohydrate. Sugars are carbohydrates. And so it's the problem is how fast are these carbohydrates entering the bloodstream? And so are we creating that nice gradual rise? Or are we creating a spike?
And that speed, right? Mm-hmm. And the speed of that conversion is based on the processing of that carbohydrate, like exactly. a brown rice versus a white flour, all these things.
And we classify this as simple carbohydrates and complex carbohydrates. Complex carbohydrates take longer to break down and for those sugars to enter the bloodstream. And then the simple carbohydrates, they just digest like that. And sugars, the sweet things that we eat, the sweeter it is, the simpler it is, and the faster it's moving into your bloodstream.
Great. Because I find it so interesting, because sugar is so addictive and satisfying on so many levels. And I think because initially it's this concentration of life force, because we're breaking down all these foods into, like you said, the building block of the life, which is the glucose feeding our cells so they can function. So here's this like hit of glucose. So I think it has this kind of trick in the brain that says, oh my gosh, that's the thing I'm always wanting. I don't even have to break it down. Here it is. And then you take it in. And like you said, it doesn't have to be broken down. It goes straight to the blood. And then the body goes into this panic response, essentially, of we have to turn this into a triglyceride so it doesn't kill me.
Yeah.
Now, when it goes there, where does adrenaline come in?
The adrenaline comes in with the subsequent reaction that occurs after you have this large release of insulin to bring down your blood glucose. You have to bring down the blood glucose. You will die of diabetic coma. So now your blood sugar, it's not just drifting down in a gradual little drop after you have this massive release of insulin to combat this spiking of the blood glucose. No, you just drop through the floor. We have, as fast as you were going up, that's as fast as you're coming down. Now we have the opposite problem. Because if you do not have enough sugar in your bloodstream, your brain will shut down. Your brain is dependent upon this glucose to be able to think, to be able to send a signal to your heart to say heart beat, to send a signal to your kidneys to say kidneys filter blood. Every single function in our human body is controlled by your brain. And if your brain doesn't have the fuel to send the signals to say do the work, then the work isn't done. So your blood sugars are coming down so rapidly right now, the body goes, oh no. A few minutes ago, we were worried about diabetic coma. Now we're worried about insulin shock. Insulin shock is another fatal condition, but this means there's so much insulin in the bloodstream and it's converting sugar so rapidly into triglycerides, which are fats, which are no longer going to be useful for us in the mitochondria to keep the brain cells going. Now, we're going to have to produce sugar for some place. So by now, you're on your sixth donut and you feel, okay, I've had enough donuts, or you've eaten enough candy, you feel sick, whatever it is, you've stopped eating sugar. And we have got to somehow come up with sugar somewhere. Where are we going to come up with sugar? Because it's all been converted by all this insulin. You have to make your sugar. Can the body make sugar? Yes. We make sugar in the liver through a process called gluconeogenesis. It's all said as one word, gluconeogenesis, but let's break the word down. Gluco means sugar. Neo means new. Genesis means creation. We're going to create new sugars. But how do we get the liver to produce the sugar? And it can produce the sugar out of proteins, because you can take a protein molecule, which is basically, you need to understand carbohydrates are made out of carbon, hydrogen, oxygen. That's it, those three molecules. A protein is made out of carbon, hydrogen, oxygen, plus a nitrogen. If we could strip off that nitrogen, then we would have a carbohydrate. Well, who can do that deaminization process, stripping off the nitrogen? And amine is another, go back into languages, Latin, it's for protein, okay? So we're going to strip off that amine, that protein, that nitrogen, okay? How do you do that? Through the process of deaminization. Who does that? The liver does that. All through this, it's involved in this process of gluconeogenesis, creating this. So we strip away this nitrogen, which is going to create a problem for the kidneys, because the nitrogen is now free floating in your bloodstream, and it attaches to a couple of hydrogens, actually 3 hydrogens, and we have ammonia. Ammonia is deadly. And so immediately the kidneys jump into action to slam a hydroxyl particle onto it, which is OH. It's an oxygen, hydrogen, to turn it into urea. And then you're adding to the urea cycle and strain on the kidneys. You're straining the liver because we're trying to convert, get things to happen and make sugar. Okay, so, but to make this gluconeogenesis happen, I mean, it just doesn't happen every day. You have to have a trigger. You have to have something to say, please do this chemical reaction, liver. What's the trigger? You have to have a release of adrenaline. You have to have a release of adrenaline, very specifically norepinephrine, which is one of the components of adrenaline. And so Well, who makes adrenaline? Your adrenal glands. And adrenaline is this great feeling. I've got energy. I can think so clearly. I'm going to get out there and take over the world, feeling. Well, that's what we get when our sugars are falling. That's why people get up in the morning and they say, I really don't want to eat, even though their blood sugars are low. I don't want to eat anything because I feel so bright and so alert and so on. Well, that's because you're running on adrenaline because you didn't eat during the night. And so you're into the process of gluconeogenesis, and you had to release adrenaline to trigger that process to happen.
Or I can't do anything until I have my coffee.
Or yes, and because what does coffee do? Stimulate adrenaline.
Right. This is amazing. So to backtrack, to kind of review that. So I'm having a delicious dinner, a bean-based meal, and I'm finishing it and I feel good. And I'm like, I think I want a big slice of vanilla cake. And I get my I get my slice of vanilla cake and I'm eating it. And into those few bites, I'm already going into this place of needing to create insulin. My body's already saying, whoa, too much sugar, need to create insulin. Before I even finish the cake or after I finish, I'm curious time-wise, when am I going into the adrenaline?
That would depend on if you ate such a good dinner, of your beans and your protein, it will be a longer time because that is actually slowing the absorption because you have so many things in the gut at that time that are trying to be broken down and metabolized. It slows the absorption.
Got it. So if I'm having
if you had that vanilla cake all by itself, we're talking less than 5 minutes, the whole reaction.
So before the cake's finished, the whole thing's happened. Before I've even finished the dessert, I've already gone through a huge imbalance in my system.
Yes.
That's amazing.
Yes.
Yeah. When you're saying that, I was just thinking of I was thinking again of adrenaline because your work is so adrenaline based. My work as a trauma therapist, so adrenaline based. And I just think it's interesting that we wouldn't think of sugar equaling adrenaline, but it does because of the imbalance from the insulin and the adrenaline needing to be the catalyst to turn this protein molecule into sugar so we can use it because the insulin has gotten rid of all the sugar. Yes. So I just find it interesting, and I want to understand what are the repercussions on the endocrine system essentially from going into that kind of pattern.
It is an overburdening of the adrenal glands to continue to produce this high amount of adrenaline. It is the same as being a paramedic, a fireman, a policeman. We see those professions, we call them adrenaline junkies. They're not on purpose trying to be, an adrenaline junkie, but their occupation, they're always responding to an emergency, and so you have to be adrenaline driven because we respond with adrenaline in emergencies. And so we basically have just gone through an emergency situation. Not basically, it was an emergency situation. You were going to die of insulin shock. And so you put yourself in this emergency crisis mode constantly. And everybody is fully aware. I mean, we've got tons of scientific studies, but I mean, you just have to look at your life. If you are constantly on and constantly in an emergency stressful situation, what does that do to you eventually? You just go, I am exhausted. I can't take this anymore. And then to get your adrenals to respond in a normal way, you have to do lots of caffeine. Go get your energy. I was about to mention brand names, but we have these energy drinks, these high energy drinks, or pop caffeine pills or whatever, and stimulate this production of adrenaline because you have worn out the glands. They're so tired. They need a chance to recover before they respond to the next emergency. And that's we create adrenal fatigue by this constant intake of sugar.
Do you know the amount that when I was researching sugar many years ago, I kept finding consistently that 8 grams, when it was over 8 grams in a serving, that's when you went into this panic mode. But have you learned any more about that?
I always use 5. That's mine. My cutoff is 5 because anything past 5, it's going to start this roller coaster reaction. And then if you go up to 8, then you're into a very severe reaction. And then, if you look at the serving sizes of sugar on some of these products, It's not just 8, it's 12, it's 36, it's 72 grams per serving. It's just like, what are we thinking? So, yeah.
I remember seeing a study that I think it was in 1900, the consumption for sugar in America was 5 pounds a year. And
Mhm.
then I think it was 1980 or 1990, it was 100 pounds a year. So it was
Yes.
this, I mean, 5 pounds a year is like really small compared if you think about daily.
Mhm.
And at 8 grams is a teaspoon of sugar. So it's good for people to hear that here so they can visualize. You're talking about half a teaspoon or so is what the body can actually handle. Now, how often does someone use half a teaspoon of sugar?
Yeah. Yeah. And it's in things naturally too that are high that we think are okay. Like if we take a cup of milk, there's 12 grams of sugar in a cup of milk in a serving. 12 grams is already over your 8, my 5. We're already, that's why diabetics, if they're in insulin shock, if they don't have any candy around, they just drink milk because it's so high in sugar. Naturally occurring, but we say it's okay if it's naturally occurring. It doesn't make any difference to your body whether it's naturally occurring or not. It is still going to do the same reaction.
So that's really important to reflect back that it doesn't matter if it's a naturally occurring sugar versus an added sugar, because you'll see a lot of advertisements on products, no added sugars. And you look on the back and they're like, I'm thinking of oat milk, right?
Yes.
Oat milk has a lot of sugar because they separate the sugar or the glucose, I'm assuming, from the fiber, like the bran, the hull. And so in that milk, when you look on the back, it says 7 grams in a cup. And on the front, it says no added sugar. So the mind says, oh, okay, there's no sugar in this.
Yeah.
But you're still going through the same reaction, correct?
Exactly. You're going to have the same reaction.
Wow, that's amazing. So I'm curious, what when you say endocrine, because we're talking about the pancreas and insulin, and then we're talking about the adrenal glands and adrenaline. If those two are being exhausted like a seesaw, right? Whenever we have this sugar, and for some of us, we're having 30, 40 grams per meal. It's not just like once a week. It's like 3 times a day. You're having maybe 120 grams of sugar. What are the long-term effects that you see in your practice in the hormonal system, in the endocrine system? How does that show up?
The first thing that happens is your pancreas wears out. And so when your pancreas wears out, it cannot produce the insulin that is needed to regulate your blood glucose level. And so then we have type 2 diabetes occur. And then we take oral hypoglycemics. What's an oral hypoglycemic? It's glipizide. There's a lot of them. And that's just a kick to your pancreas saying, come on, give me more insulin. And so like you're squeezing the pancreas saying, give me more with those drugs. And then you have, of course, people, then if you still can't control your blood glucose levels with your oral hypoglycemics, then you go into taking insulin by injection. You're just taking the insulin that your pancreas won't produce. Can your pancreas recover and produce the insulin? Yes, it can. It's produced in a very specific part, the Isle of Langerhans, and then the beta cells, and they can recover, but it's a 3-month recovery operation for those cells to go through what's called a mitosis and create new cells. That's the pancreas. Even before you get to diabetes, though, with your pancreas not functioning well, your adrenals are going to be so fatigued because they're constantly in this crisis mode, another crisis, because we can go through, you think about how often people eat sugar in a day. Oftentimes they're eating it every meal, so 3 times, and then they have a sugar snack mid-morning, mid-afternoon. And what good American doesn't have a bowl of ice cream before they go to bed? You know, it's and so you have it 6 times a day. And so we're going through these emergencies 6 times a day, responding to the code blue, while you're running to save someone's life. It's your life you're running to save. And so your adrenals become exhausted. And so what does that? You're tired. You're so tired. And you can't think very clearly. And you have this mood swing. You're Dr. Jekyll one moment and Mr. Hyde the next. And as time goes on, you sink into depression and anxiety. And now we have mental disorders like bipolar, schizophrenia. I mean, we can go into, there's a whole gambit of mental disorders that we get into. And, oh, I have a brain chemical imbalance. Well, what's the brain chemicals? Well, you have to understand, we have over 100 different brain chemicals. They're called neurotransmitters. And the most prominent one that we make and use all the time is adrenaline, epinephrine, and norepinephrine, made where? In the brain? No, made from your adrenal glands. But now we don't produce that. Either we're overproducing for the emergency state, and that gives us anxiety, or now we're underproducing. And then so we don't have enough to be able to make the brain cells communicate through neurotransmitters. We don't have enough of those neurotransmitters, so we don't communicate, so we sink into depression and we can't think.
And that's specifically from the excess of adrenaline.
Yes.
Throwing off all those other like serotonin and other hormones.
Yes.
That's amazing. So the way that the sugar and the adrenal response, and I think I should say the chronic sugar and adrenal response, over time imbalances those hormones that essentially keep us balanced so we can feel joy and love and connection. So
yes,
this is like where the nervous system is impacted.
Yes.
That's amazing. What are your thoughts, like when I said the word chronic, what are your thoughts about someone that once a week I have this cookie I love?
It's, a chronic, when we intake chronically every day sugar, then we're going to see the most effects. Once a week, you are going to have a detrimental effect in the long run, because we have 52, 52 weeks a year, and then the years go on. And I haven't even gotten into how sugar changes your DNA and causes mutations, how it lowers your immune system function by bringing down your neutrophil's ability to fight things. And so you are, even once a week, you are not going to be living at the optimum. I put us into 3 classifications. We have disease state. That's the lowest state. We're in disease. We have diabetes. We have cancer. We have arthritis, because I haven't gotten into how sugar also causes arthritis. We can get into that. It causes inflammation. But then, so there's the disease state. That's the bottom level. We don't want to be there. And then we have this, I call it mediocrity. The mediocrity is the sugar once a week people. A little bit, it's not going to hurt me. Once a week, it'll be fine. And so most people live in this mediocrity. They feel okay, they get along, they can do their jobs, and they can eat sugar, on this once a week basis or however often, and they can survive. They're not down there in the disease state, although in time, as the years roll on, they will end up in the disease state. And then there's this place, Louise, of optimum health. And this is the place where I like to live, and this is where I live. I am above the mediocrity. I'm at this place where I'm always on, but not on an emergency on, where I am thinking, I am so full of life. I have energy to do so much. There is hardly a day that goes by that someone doesn't say, how can you do as much as you do? You're a veteran and you're over there doing the military honors for the funeral. Now you're organizing the fire effort for the building that burnt down the community. You're a village trustee. You're also getting another master's degree at the same time. Oh, in addition to that, you're producing movies. Oh, and you run a full-time business and you're helping literally thousands and thousands of people, and you're doing podcasts, and you're also, and you write for 4 different newspapers too, a history column, and you're in the historical society. Oh, and you're also in the Lions Club, and how can you do all this? Because I'm at this optimum level, and I have energy abounding. I love life, and I can be involved in all of this. And I spend gobs of time with my grandchildren and my family, and on and on and on. And it's so worth it. Do I eat sugar once a week? Never. Do I eat sugar at all at any time? Never, ever. And haven't for over 3 decades after all this full knowledge came to me. And I am in my 60s now. I will be 64 in October. You're looking at me. I'm not wearing any makeup. I'm not dyeing my hair. I am here. And this is the way I am. And this is the way I want to be, because I want to continue all these incredible things. I want to live to that 120, because we have the possibility to live to 120 years. And so, and that has to do with end caps on the chromosomes, and you might recall telomeres. That's another story for another day. But if we're living at that optimum place, then you can do all this stuff. All my peers, they're all retiring now. They're all drawing Social Security. They're all making out their wills and, figuring out what nursing home they're going to be put into. Not me. I'm I'm just getting started.
Mm.
Because when you get to my age, you finally have enough years behind you, that you have enough experience and learning and knowledge that you can bring all this to bear. And now I'm just at that place where I can become really fruitful in my career and in all that I am doing. And so this is when most people say, well, I'm retired, I'm moving to Florida. Nothing wrong with moving to Florida, by the way, but, or Arizona, where it's warm, and get out of this crazy cold in Wisconsin. And then we give up when we're in the prime. I have just entered the prime of my life. And this is when I can accomplish more than I've ever been able to accomplish in my life. And so I got another 57 years of going out there and really doing something to help people and change the world. And that's living at the optimum. So I'm not interested in sugar once a week because I don't want to be in the mediocrity, and I just sort of, plow along and I get things done. I'm okay.
I mean, my heart is so full right now, just watch it. This is why people are so attracted to you, because it's like if you were if you were walking into the room and you were like a little achy and you were kind of like burping and you were kind of like trying to find your words and you're talking about, health, it'd be like, oh, okay. But, you are this extremely vibrant source of life. You have so much life force in you. I mean, that's obvious. And you're quick. And I love, it's interesting. I was talking to my wife last night about this. I was saying, because we have a friend who's, I want to say, going to be 61, either 61 or 62. She's been on your protocol for a year. Before that, she looked great because she's been just an optimum diet for many, many decades. But since the bean protocol, I mean, she looks like she's 30. And I remember saying to my wife last night, I said, I can't believe that she is going to be 61. My grandmother was going into a nursing home around 66. And so 2 years from where you are right now, 5 years from where she is. And I'm so inspired by, these elders that we have who are not the stereotypical elders, who are like you just said, I'm in the prime. I mean, that's so beautiful. No one thinks, I shouldn't say no one, the standard American concept of your 60s, like you said, is you better retire because after that it's downhill. Like you need that safety net of retirement. That's why people work their ass off for 30, 40 years. But to be 64 and to be able to say, I'm just stepping into my life, that's so inspiring. Yes. I just love hearing that. Yes. It's so beautiful. And I think when you're talking about, when you're saying, you don't dye your hair, you're not wearing makeup, you have all this vitality. In my mind, I was hearing, oh, that's the nature of the body when it's being fed exactly what it needs, right? When it's not going into these states of debt. I really see it like debt, like energetic debt, like taking in too much of something, whether it's fat or protein or glucose, and all the work the body has to do just to balance it. In that process of balancing is aging you, correct?
That's correct. It's exactly correct. It's the process of aging. When we're imbalanced, we age more rapidly. And so, the average life expectancy, well, we can look it up in the, the World Health Organization stats or whatever, but it's in the United States, it's in your 70s, And so, well, we just fear we're going to die. Well, isn't that about 50 years short, 40 to 50 years short of when we should be? Yeah, all that we could give, all that we could do.
I think of a lot of about indigenous cultures, and my grandfather actually just passed away last week, but it was a very beautiful death. I'm very at peace with death personally, but he had a beautiful faith, and he felt very like good. He wasn't scared. He was almost 92, and he grew up on an indigenous Puerto Rican culture. So his cuisine was really simple whole foods. It was like fish, avocado, beans, rice, vegetables. Never ate sugar, never ate fast food. And he was like unstoppable. And then in the last decade of his life, he started eating more fast food because my grandmother passed, and they had a very traditional role. And so he lost that person that took care of him, like with food in that way. And maybe he was depressed, I'm not sure. But even so, he still had a beautiful, healthy death, if you will. You know, it was very natural. He was sleeping peacefully. We were all around him. And so he like exited in this beautiful way, because his whole life, the foundation of his body was in this practice of optimum living. He really did. He had endless energy. He worked for the army. He was a mechanic, and they made him retire because he wouldn't. He was just he refused to see. He would have still been doing it till last week. So you know, I had the pleasure of experiencing that intimately. You know what you talk about, and I'm just saying this because when you said the life expectancy is, it's such a modern life expectancy, because if you look at ancient cultures, and I always say indigenous cultures, you know, cultures that grew around a certain land and ate from that locality, they're just 90s, hundreds. It's very normal for them. It's not a big deal. So what you're saying to me isn't, it might sound far-fetched for people, but to me it's very natural. It's how we actually move on this earth when we just eat the earthly foods, right?
Yes. Yes.
That's
Yeah.
that's really
I mean,
beautiful.
all those indigenous foods. I mean, you didn't have cupcakes, you know, and you didn't have little, candy bars to eat, or so yeah.
Right, right. You know, I'm thinking, oh, actually, we're just about done. Let me think of, I had one more little question for you. I guess I would ask you if it's possible in a couple minutes, and if not, this is a good cliffhanger for next time. What's the relationship between sugar and DNA?
What happens is that sugar has the ability to actually, there's something called a kinase, a protein kinase C. Um, these are, they're very prolific, that we make in the human body. And whenever we have a high sugar intake, it activates this protein kinase C. And this is it's a multifunctional enzyme that's going to trigger different cellular processes, but it is very much involved in the control of gene expression. And a lot of people get very confused, especially with genes, and the research is new. I mean, we just finished typing the genome, in the 1990s, and so we're all into the genetic research, but we get convinced that we have these, like we have the BRCA gene. If I have the BRCA gene, I'm going to get breast cancer. Well, no, not necessarily. You have to activate that gene. And these protein kinases are really essential in that gene expression. So you may have a gene, but it has to be expressed. We have mechanisms to turn the genes on or turn the genes off. And the sugar is one of these things that turn the genes on and turn the genes off. And that's called epigenetics. It's a whole study of genetics, so that the environmental factors, and we always think of environmental factors as air pollution or something like that, but it means also our diet and what we're consuming. That changes the expression of our genes. Then in addition to that, we can have, when we make these hormones that we've talked about with, like the adrenaline, and you're stimulating the entire endocrine system. Hormones are very, very tiny molecules. And every cell has a barrier to prevent things from just entering the cell. I mean, we have to have a protective coat, if you will. In a plant, we call it a cell wall. In a human being, we call it the plasma membrane. Well, you can't just cross the plasma membrane. Nothing can just go across the plasma. You have to have permission to get inside the cell, because if you get inside the cell, you can change the whole function of the cell and ruin that. And so there's like G-coupled receptor sites, and there's ion channels, and there's different ways that you can get into, molecularly can get into the cell. Well, when you're talking hormones, they're so tiny, they're so little, they don't have to have a doorway to get through the plasma membrane. They diffuse. Diffuse means they just walk through the wall. They just go right through the plasma membrane because they're so tiny. They just wiggle their way through. Actually, this is like they walk through the wall. And then they enter the cytosol. And the cytosol is the space, the fluid in between all these organelles inside the cell. And then immediately, because of their structure, a transcription factor will attach to it. Well, what's the significance about that? Because when you have this this hormonal transcription factor compound, it will immediately travel to something called the nuclear envelope. The nuclear envelope is inside each cell. There's a second little protective barrier. That's a nuclear envelope, because inside the envelope is something very, very precious to every cell, and that is your DNA. You have a full copy of your DNA in every cell in your body, with the exception of neurons and red blood cells. They don't have a copy of your DNA. Okay, so all the rest of your cells have a full copy of your DNA. And so if you cross that nuclear envelope, and you're going to do it through diffusion, because you're still so tiny, because you have nuclear pores that will only allow certain things to in and out of the nuclear envelope. Then this transcription factor through diffusion crosses in, and you have exposed it to, your whole DNA is now exposed to what? This hormone, this with the transcription factor attached, it just latches onto your DNA, and it's random where it latches on. It's just wherever it just lands, it lands and attaches. When it attaches, a chemical reaction will change, and you swap out this nucleotide sequence. Nucleotides are these very particular substances that are put together in 3 members, are called a codon, and then they form your DNA. And then if you swap out the sequence, you just changed your DNA sequence. Well, if it's in a place that doesn't matter, then you'll probably never notice. But if it's on the P53 gene, if it's on that another gene that's important, then it's a mutated gene, which then when that cell reproduces, that mutation is copied exactly. So the mutation goes on to the daughter cell, and the daughter cell after that, and after that. And so you're carrying these mutated problems. And so the more mutations you have, the more at risk for cancer you are. Because what is cancer? Cancer is a disease of it's mutations on the DNA.
I would love to have you back just to do a whole episode on that, because it sounds very rich and very nuanced, and it's interesting because it speaks at the micro level of the work I do with intergenerational trauma amongst family members. You know, how one person will pass their trauma response to the next when it's unresolved. It's the same thing you're talking about with the DNA, because that cell, the offsprings, right, of that cell have this coding that is getting expressed until it gets healed, essentially.
Exactly.
That's powerful.
Yeah.
As always, I'm endlessly inspired and honored to learn from you. And thank you for coming on here and doing this for free and teaching all of us. And it means a lot.
For people to live at that optimum level. Come on up.
Yeah, I know you do. And we are, thanks to you. We really are learning how to. So we'll have you back soon, okay?
Okay, sounds good.